Okay, so it works. Thank you for introducing me. And I'm Yutaro Sasaki. And today's talk title is Making Automatically Compliant Design Documents with Infrastructure as Code. And okay. Next. Okay. And today's goal is to understand the background about background and what is system integration business in Japan, and what is the importance of parameter sheets, which is most detailed design documents. And I will introduce you to the as the three key factors. And the latter part is the technical topics. And I will introduce the history of our ISC approaches and our new ISC approach divided into three key points part. And the picture, you can see the picture on the right bottom. This is an overview of what we need in the infrastructure automation. And this is the agenda of today's talk. And the section 1 is about the background and what is SI business in Japan. And the second section 2 is, I think it is a unique part because many deep dive sections is related to technical elements, but today's talk is deep dive into the parameter sheet. It is one of the design documents. It is not so techy part. And finally, the section 3 is here's the techy part and ISC approaches with parameter sheet, and start with the history of our ISC approaches. And I will introduce you to 3 key points and best case scenario. And let me introduce myself. And I'm Yutaro Sasaki, and my affiliation is Technology and Innovation Headquarters, Entity Data Corporation, which is located at Tokyo, 20 miles away from Athlete Village this year, 2020. And this live stream is conducted at from Saitama Prefecture next to Tokyo, by the way. And specialty is server virtualization and infrastructure automation, including Puppet, Chef, Ansible, Server Spec, which is unit test framework tool, and the Terraform. And recent activity, 2.5 years ago, I published a book, Puppet Practical Guide, and I talked on Japan Java User Group, and also talked on the NTT Data Technology Conference, September 2019. Okay, in this section, I will introduce what is system integration business in Japan. As a system integrators, we build an optimal system for customers based on customers' requirements. And we, NTT Data, is not specific hardware vendors, so we can choose any hardware, any package software, and any network infrastructures. And because of that, we can build an optimal system for the customer. And these days, as you know, many infrastructures moved into cloud infrastructure. And so my department is in charge of cloud technology. And as I mentioned, NTT Data is not hard, specific hardware vendor. We can choose any cloud, and our policy is utilize any cloud, um, including public cloud AWS, Azure, GCP, and the private cloud VMware and OpenStack. And I don't tell you much about this slide, but the most important thing is any cloud policy perfectly fit the IAC software Terraform. And Terraform provides many providers which you can utilize the many PaaS cloud, SaaS cloud, and IaaS cloud. And section 2, deep dive into parameter sheet, which is the most detailed design document. And as I mentioned earlier, we are the system integrators, and we have to deliver deliverables. And as part of deliverables, engineers in dev teams need to arrange architecture design document and detailed design document, including parameter sheet. And of course, it is highly required that design document and the system are surely consistent. So, what does delivered parameter sheet look like? Here is an example. This is an example of Red Hat Linux and regarding kernel parameters. And you can see the many parameters on the table. And from the left, here is parameter names and default values. And there are two kinds of default values, which is one is default behavior when this parameter is not on the configuration file. And the second one is default values described on default configuration files. They are totally different. And the third one is actual values in environment. Here is an example of 4 servers. And next one is parameter description, and which is what these parameters behave, or what parameter means. This kind of information is usually on the manual or man page of the command. And finally, design policy. This is the most important part in the design document. So why and how this parameter value are set on the server. This is the design policy. And high-level expectation for the parameter sheet and issues. And the high-level expectation for parameter sheet is making implicit design knowledge explicit and avoiding secret sauce. And also reuse and distribute as a best practice. But in reality, inconsistencies occur between design document and actual servers, mostly because of human errors. So we think we need automation solution from design document with IAC software. And what is the key factor of parameter sheet? And parameter sheet are very meaningful in typical SI project. And here is the 3 key factors. The first one is only document showing the status of the actual machines. And second one is explicit document that describe most detailed design policy. And third one is a communication tool between dev team and ops team. And regarding the first factor, the only document showing the status of the actual machines. But here is a simple question. Is it the most reliable way to directly investigate the actual machine? The answer is yes. However, for security reasons, the actual machines are not easily accessible in most cases, especially in on-premise data center. An application form for authorization must be submitted days in advance, and only the planned and permitted operation can be performed. So you cannot invoke unplanned and ad hoc operations, and they are strictly prohibited. And even if they are easily accessible, it's hard to compare between many servers. So if we want to compare between many servers, first SSH. Oh, we have an amazing tool, parallel SSH. But after the gathering data, we have to compare diff command, and how to compare more than 3 files, and there is actual issues. And the second factor is explicit documents that describe most detailed design policy. And maybe developer might think, I comprehend the design policy. I couldn't understand why I have to spend much time on documentation. I agree with that. But actually, we should assume the engineers leave the project sooner or later. So explicit knowledge is very important in especially operation phase. So suppose that a few years after the launch of the service, a parameter change was suddenly required, such as a heartbleed or something like that. And operator might think, can I change this parameter? And guys I know says this parameter has changed many times, but I have no idea how and why it happened at all. So it is so-called secret sauce. And third one is a communication tool between dev team and ops team. So dev team offer a very specific and clear information to the operator. So there is no room for interpretation. And the parameter sheet fact. Parameter sheets are one of the most frequently modified documents in actual project. And because parameter sheets are the most detailed and specific design documents, they are often affected by operational changes such as adding new users or security updates. And here is one more thing I have to tell. Documents in binary format are difficult to integrate with version control and IAC software. Traditionally, design documents are in Microsoft Office format such as Excel or Word, and therefore we have needed to extract values somehow for integration with Git and Terraform. Okay, let me summarize of this section. The most important thing is parameter sheets are necessary but have some difficulties. And what parameter sheet in SI project? It is part of deliverables and is one of the most frequently modified documents. And 3 key factors of parameter sheet: the only document showing the status of the actual machine, an explicit document that describe most detailed design policy, and the communication tools. And difficulties in integration with version control and IAC software due to binary format. Okay, section 3. Here is a techie part, and I share projects with parameter sheet. And this slide shows you about the history of our IACA projects. And blue line indicates the automated task, and dashed line indicates a manual task. And prehistory, more than 10 years ago, um, the process is not automated at all. So developer looking at the parameter sheet and the procedure manual and manually construct and manually test with the server. And this is not good at all. And everybody in this, every audience might agree with that. And second one is a traditional IAC approach. And this is automation code transcribed manually, but once automation code is created, the creation and testing part is totally great by the automation code. But the former part, manual data transcription is might be a cause of the human error. So we thought the ideal IAC approach, automation codes are generated automatically from the design information. And this is our initial approach in the past. So traditionally, we have used a parameter sheet in Excel format. So if we predefine a unified format in Excel, maybe it is useful, very useful in a SI project, especially in Japan. And from the parameter sheet in Excel format, we can convert data using a Python script and convert into the automation code, such as a TF bus of the telephone or host bus file of the Ansible, something like that. And this is very great, we thought at that time. But in reality, difficulties remain. Something like users start customizing unified format. And data extraction logic is relatively complex because parameter sheet is contains both data elements and view elements. And finally, parameter sheet cannot be completely under version control because it is not a plain text format. So we invent the new IAC approach. And here is an overview of our new IAC approach. And here is 3 key points. The point 1 is the separation of view and data. And point 2 is integration with version control software and we use as best practice. And point 3 is the separation of logic and data. And point 1, separation of view and data. As I mentioned, we defined a plain text design information format and the editor, which can open and edit and view and save the file. And it also can export the parameter sheet in Excel format because we sometimes need Excel format parameter sheet as a deliverable. And data files are always in the plain text format. So it is primary information and also a single source of truth. And point 2, integration with version control and reuse as a best practice. because new design information format is in the plain text format, um, it is a very good relation with version control such as Git or SVN. And we call it semantic design format, SDF. This is actually an extension of CSV format. And technically, this format is, for example, YAML format or JSON format acceptable. But why we choose CSV format is it is based on the line-oriented format. So if we look at the changes in the Git log, we can easily detect what parameters are changed, and these parameters belongs to what parent category. So that's why we choose a CSV format. And this is point 3, separation of logic data. And this is here is a example code snippet, which used to create a new VM on a VMware environment. And code on the left is logic part, and the code on the right side is data part. And as you can see, the left side is very generalized and using a loop syntax, including dynamic syntax. And as you can see on the right side, new VM name is a node 1, and VM folder is a slash folder, and VM disk size is 20 gigabytes or something like that. And using this generalized and shared automation code part, we can assume the best case scenario, which means the developer only have to edit design information in order to add, change, delete parameters. So in this case, assume that the developer, oh, I forgot adding disk 3 and need to deal with it as soon as possible because my boss told me. And all I have to do is to edit design information file. It's easy. It's easy. But however, of course, if the generalized or shared automation code doesn't contain the new parameters, the developer need to fix the shared automation code, which is the logic part. Okay, and the final part, difference and conclusion. Talks relating to this ISC topic is conducted 2 times in Japan. The first one is NTT Data Technology Conference 2019. It is in September last year. And the slides is on the slide share, so you can see it, but it is Japanese only. And second one is Red Hat Forum Tokyo 2019 in November 2019. And the solution, our new ISC approach, is part of our methodology, TerraSolna, and currently is not OSS software. And conclusion, we invented a new ISC approach from design information to construction of the infrastructure and testing infrastructure. And we will continue to broaden the coverage of automation with ISC technology. And thank you for your attention.